additional topics in mathematics, imaginary numbers, and these are very fundamentals for complex numbers, very fundamentals for complex number concept. And it's a very small chapter. It's a very small content, and maybe we don't need to cover too many things for it. And so we're going to start with imaginary number essentials. And before we're going to start with the imaginary number essentials, we just need to let you know that how do you calculate for any kind of number? That is, for an example, that is under the hood of root, a squared root, and it is like, for an example, -4. How do you calculate this? How do you calculate this value? So this is where the question arises in the mind of the mathematicians, the famous mathematicians. How do you calculate? How do you calculate this problem? How do you calculate this problem? Because we know, whenever we're just doing some square of anything, for an example, this if a is a number, and we are doing a square, we're taking a square of this number, then what happens? What does it really mean? What is the mathematical interpretation? What is the mathematical interpretation? Whenever we're just saying that it is written a squared, we're doing a cross a. Okay, fine. But what is the meaning of this mathematical expression, or what is the mathematical interpretation? It means that we are just gonna multiply. We are just gonna multiply this number with this number 2 times. We are just gonna multiply this number with this same number 2 times. This is 1 time, this is first time, and this is second time. This is first time, and this is second time. What does a to the power 4 means? If a is a number, then we just need to multiply a with its own number a 4 times. Number 1, number 2, number 3, number 4. So for an example, if we write 5 squared, what does it mean? It means that we just need to multiply 5 with the same number 5 2 times. Okay, so if we just calculate this 5 times 5, it becomes 25. It's positive 25. So, okay, so fine. So tell me something, and you are just gonna doing some square stuff. You are just gonna doing some squared stuff, and you are getting a negative answer. You are just getting a negative answer. Just consider such a situation where negative 25 is the product of same two numbers. Negative 25 is the product of same two numbers. Negative 25 is the product of same two numbers twice. Negative 25 is the product of same two numbers. You just need to find such a number. Which is going to be the same. Just like, for an example, x cross a. X is the same, and this is also the same. And you just need to find negative 25. You just need to break it. You just need to make it into pieces. Into 2 pieces, alike, similar looking. I'm sorry for my mistakes. Similar looking 2 numbers, and you just need to multiply them, and in the result, in the output, you're just gonna get a negative. You're just gonna get a negative sign. And from our basic concepts of algebra, we know that if you're gonna multiply a negative number with a negative number, you never get a negative number. You always get a positive number. Do you understand what I'm talking about? Do you have any questions?
No.
Do you have any questions?
No.
Okay, fine. If you have any question, please let me know. Please let me know. So this negative number and this negative number, whenever you're just multiplying it, you're just getting the positive number. So is it really possible to get a negative answer, a negative answer, a negative answer, and in the meantime, you're just multiplying two similar numbers and you're getting a negative answer? No, is it really possible in your real world? No, it's not really possible because if you're gonna multiply plus 5 with negative 5, then you are not getting, then you are not multiplying, you are not multiplying the same number. You are not multiplying the same number. No, you are not multiplying the same number, the exact same number. The exact same number. You're not multiplying it. You're just multiplying two different numbers. Multiplying two different numbers. The meaning of multiplying two same numbers mean that you're just gonna multiply plus 5 with plus 5. That's the meaning of multiplying same numbers. Or for an example, you can multiply plus 7 with plus 7. That is called that is the meaning of multiplying same numbers. Or you can multiply negative 3, and that is negative 3 whole squared. That is the meaning of multiplying same number. But for this output, this is the output, this is going to be the output is going to be the negative, the output is going to be the negative, the output is going to be the negative number, but the input will be the same number, same number, whatever it is. Maybe it can be positive or maybe what can be negative, whatever it is, you just invent something else, or etc. else, and the output is going to be a negative. That's not possible in your real world algebra system. For an example, if you're just going to multiply with a negative and a negative number, you get a positive number. If you're going to multiply a positive number, with another positive, the same positive number, you're also going to get the positive answer. Yes, definitely. If you're going to multiply a positive number with another positive number, you get a positive number. I'm just trying to relate it with this concept, okay? And that's why I'm just mentioning the same number, because doing square stuffs, meaning that multiplying the same number again and again, 2 times or etc. If you're going to do the cube thing, you're gonna multiply it 3 times. If you're just gonna do the to the power 4, you're gonna multiply it 4 times, and that is it. So it's not possible, and that's why we just need to introduce. And that's why, because in a real world algebra system, we really cannot get a negative number output as the output, negative number as the output. We cannot get a negative number output in the case where we are just inputting the same positive or negative number. We just need to give some input. We just need to give some input of some different type of numbers. What is that number? So that's why mathematician, I'm not mentioning the exact mathematician name who introduced it first, but if you just gonna get some historical backgrounds, then definitely there will be so many things written about it. So we are just gonna introduce a number which is called iota. This is called iota. This is a Greek number. This is a Greek letter, iota. So this I is the imaginary unit. This I is called the imaginary unit. This I is called the imaginary unit. And this I means negative of 1 under the hood of squared. Negative 1 under the hood of squared. And that is the reason we need iota, or the reason we need I, why we need to introduce the concept of I, that I have told you here. I've told you here, I've told you here, I've told you here, I've told you here, I've told you here. And that is the reason why iota is needed. Why iota is needed. Because we are going to multiply the same two numbers, but the output is going to be the negative. And to solve this problem, we need imaginary unit, we need iota, we need I, or which is something squared root over -1. That is it. As simple as that. As simple as that. So this is gonna be the very, very, very basics about iota. But the thing is, how do you add it? How do you do the subtraction? For an example, here we are adding this 3i, and 2i. Please remember that these are the basics of complex numbers. So I'm just going to tell you something. Let me tell you that is for an example, this is the basic. For an example, 3i plus 2 3i plus 2 is a number. This is a complex number. Okay, this is a complex number.
Okay.
This is a complex number. And this is the imaginary part. This is the imaginary part, and this is the real part. This is the real part. Maybe I should have used the some different colors. This is the real part. This is the real part, and this is the imaginary part. This is the imaginary part. Okay, so this is a complex number. And inside the complex number, we have two different parts, that is real part, and we have imaginary part. And we can add two different complex number. We can add, we can subtract, we can multiply, and we can divide. We can multiply and we can divide. We can do all of these stuffs. We can do all of these stuffs. We can all of these stuffs just like we do in the real number system. For an example, what is the real number? 5, 6, a negative 9.2, 6.66666. This is also a real number. The value of pi, that is 3.1416 dot something something something. The value of e, which is used in the logarithmic system, ln of e, log e base of x. This e is, I'm talking about this e. Okay, I'm talking about this e.
Okay.
I'm talking about this thing. This is also a real number. So we can do all of these stuff. And how do we do it? How do we do it? We just, as simple as that. You just need to add the imaginary side with the imaginary side, and you just need to add the real side with the real side. For an example, if we just add 3 plus 2i plus 4 plus 2i, you just need to add this real part with this real part, and you just need to add this imaginary part with this imaginary part. As simple as that. Okay, do you get it? Hello, do you get it?
Yes, can you hear me?
Yes, I can hear you. Do you understand what I'm talking about?
Yeah, so far I do.
Okay, you just okay, all right. So as simple as that, you just need to add the real part with the real part, and then you just need to add the imaginary part with the imaginary part. As simple as that. The same thing also goes for the subtraction. Multiplication is kind of a different. I maybe if it is necessary here, then I will show it for you. But currently, you just need to grab these concepts. Okay, grab these concepts. So they're just doing the same. And for your kind information, I square equals 1. You just need to remember some basic. I'm always suggesting you to please read some basics from some fundamental books. At least you just need to grab one complete book where you can just understand, or you can just grab some of these concepts, because these lectures are not going to cover the behind concepts, the essential concepts of every single chapter. I square equals -1. Okay, I square equals -1. This is basically a law. You can call this is formula. Okay, this is a formula.
Wait,
And
so I just regular I is 1 and I squared is -1?
I equals root over -1. I equals
Okay.
root over
Okay.
-1, and I square equals -1.
Yeah.
And because why it is happening? Because the thing is, you're just multiplying. I square means you're just what is the meaning? What is the interpretation of squaring terms? What is the meaning of the square? Doing some square stuffs mean that you're just multiplying the same number 2 times. And if you're just gonna multiply -1 with negative root over -1 2 times, then you just get -1. And that is the interpretation of I square equals -1. Okay.
Mm-hmm.
I square equals -1. I square equals -1.
Mm-hmm.
And I equals root over -1.
Yeah.
I equals root over -1. But there is a thing. The thing is, maybe I shouldn't have introduced with this thing. For an example, if it is written like root over -5 into multiplied by -4, -4. These are some very, very, very sensitive topics. And I was not someone who always got or who never ever got good numbers in mathematics. But the passion I had for mathematics, that was quite impressive. And I just cannot tell how many books I have read only for mathematics because how passionate I was. I loved physics. I always wanted to become a physicist, but now I'm studying engineering. But I always wanted to be a physicist, and my love for my mathematics was too amazing. And one of my friends always used to tell me that um, only I am the person who really knows mathematics. I'm not just bragging. I'm just telling that. Um, I'm just telling you because these are very sensitive topic and people make mistakes. You just cannot. Some people, there's a lot of people, there's a lot of people who just take this line and they just write it like this: -5 multiplied by -4. This is wrong. OMG, don't do it. Don't do it. Don't do it. This is suggested by Carl Friedrich Gauss. Carl Friedrich. I'm sorry for the name. Maybe if I'm doing some mistakes, maybe he is gonna just give me some cards from his own grave. I'm sorry. So you cannot do this, okay? You cannot do this. It's wrong. The very first thing, if you're just watching something under the hood of a square root, negative something, the first thing, the first step is to pull out, pull out the negative and write an I, an iota, and then keep the number. And then keep the number. For an example, n, -n. You just need to write it I root over n. Very sensitive, very sensitive, super sensitive, super sensitive. Anyway, so we're just gonna need to know the values of what is the meaning of I to the power n, and what is the meaning of what is the basically how do we calculate I to the power 5? How do we calculate I to the power 9? I'm just gonna cover some extra thing. Maybe if it is not mentioned here, I'm just gonna see what type of mathematics they're asking about. And if it is necessary to calculate the value of I to the power n, then I'm gonna introduce some extra concept, or I'm gonna tell you some extra mm, techniques, whatever it is. Maybe they're not mentioning it, or I'm just gonna suggest some things that is called the imaginary plane or whatever. So just primarily keep it as simple as that, just telling something. But now let's do the math. What kind of mathematics we're just gonna face in the SAT math, okay? That's very important because knowing all the things won't help you in the SAT. Knowing all the things won't help you in the SAT. Knowing all the things of mathematics will help you to be a nice mathematician or to be a good engineer or to be a good physicist, because you cannot just walk and step ahead if you are not good in mathematics. At least if you don't understand how things are working, because you won't do well. You're just gonna be scared. But just look at what types of math we're just gonna face in the SAT exam, because knowing all the things won't help at this stage at least. What is the following would be an equivalent form of the expression, okay? So they're just asking how to do it, okay? How to do it. So how, this is just a division of two complex numbers. This is the division of two complex numbers. Division of two complex numbers. Division of two complex numbers. And how do we divide two complex numbers? How do we divide two complex numbers? And we just introduce a concept called complex conjugate. Complex conjugate. We just introduce a topic called complex conjugate. So if it is saying like this, then you just need to take the conjugate of the denominator. Conjugate, complex conjugate of denominator. Denominator. Basically the topics they have discussed here, the basics that are not enough. It is not covering at least 1% of the problems they're asking us to do. This is completely just nothing. The background knowledge that they have provided, it's too low. Because anyway, so you just need to take a complex conjugate of this denominator, and then you just need to multiply it in the both of the numerator and the denominator. The same thing, the same complex conjugate, complex conjugate, complex conjugate, conj, complex conjugate in the numerator and in the denominator at the same time. That what is there they have done. The complex conjugate, this is like this, and the conjugate of 3 negative I, the conjugate of this is 3 plus I. Because if the only way you just calculate the complex conjugate for any given complex number. You just need to change the sign of the imaginary part. This is the imaginary part. This is the imaginary part. The sign of the imaginary part is negative, and you just need to change the sign of this imaginary part into the different sign, and that is positive. And the conjugate of 3 negative I is 3 plus I. 3 plus I. That is necessity is we just need to divide two complex numbers. We just need to find out the answer of division for two different complex numbers. And how do we do it? We bring a concept. We bring a concept of called the complex conjugate, and that is what we have done. That is what we have done till now. That is basically there is a numerator and a denominator. There is a numerator and a denominator. So there is a numerator and a denominator. This is the numerator. This is the numerator, and this is the denominator. And we just take the conjugate. We just take the conjugate. We just take the conjugate of this denominator. Not only for this particular type of math, every single type of division, whatever you are just trying to do, okay? Whatever you are just trying to do, every single time, you just need to do the complex conjugate of the denominator, and then you just need to multiply them. The answer becomes, that is, you are just multiplying the conjugate with the numerator and the denominator, and then you just get the answer, that is negative, sorry, 3 negative I, 3 plus I, and 5. This is also simple, okay? This is nothing but just doing some simple terms. Simple terms mean, 5 multiplied 3 plus I, which is 5 multiplied by 3 plus 5I. Okay? As simple as that. 15 plus 5I. 15 plus 5I. From this line to this line, okay? Do you understand?
Yes.
Okay. And then you're just multiplying two different complex numbers. You're just multiplying two different complex numbers. You can just expand it. You can just expand it, or you can just write like a squared minus b squared. Okay, a squared minus b squared. You can write like this. What does that mean? It means that these are some basic concepts about the complex number. These are some basic concepts about this concept of the complex number. For an example, just think like this: a plus ib multiplied by a minus ib. If you expand it, if you expand it, if you just expand it, then you just get the answer just like, a squared plus IAB minus IAB plus minus I squared B squared, right?
How
How
did
do
you
you
get
do?
IAB?
IAB. Are you
Yes.
just talking about IAB? You are just doing, okay. You are just multiplying A with this whole expression one time. And this is gonna be like this.
Okay.
And then you are just gonna multiply this with this same expression again, with this same term again. And then
Okay.
you get this, okay? You
Okay.
get this.
Yeah.
So if you just think about it, then this IAB and negative IAB be cancelled, are cancelled by each other, okay? And the
Yeah.
final term that remains, that is A squared minus I squared negative I squared B squared. And we already know I squared equals -1, right?
Mm-hmm.
That's a formula, and that's the basic of iota. So I squared equals -1. So minus I squared equals -1, B squared. I squared equals, so I'm sorry, this, there will be no 2. There will be no 2. There will be no 2. Sorry, there will be no squared. So this is big. So this becomes, A squared minus, sorry, A squared plus B squared. A squared plus B squared. Right? I think this is it. The shortcut maybe. A squared plus B squared. So A squared plus B squared, B squared. So 9 plus 1. This is 10. Exactly. Exactly. Do you understand what I'm doing?
Kind of.
Okay. I'm just gonna tell you it again. Okay. Basically, we're just multiplying two different complex numbers, but the complex numbers are conjugate to each other.
Yeah.
We are just multiplying two different complex numbers, but the complex numbers are conjugate to each other. What does that mean? It means that this is this is, just look at my pen. Look at my pen. This is a complex number, and this is also a complex number. I have just highlighted it. Okay. So both of them are basically conjugate to each other. And what is the answer? What is the answer whenever you are just multiplying two conjugates number? What is the answer? What is the answer of multiplication of two different complex conjugate numbers? What is the answer of the multiplication? What is the answer of the multiplication? Do you understand? What is the
Mm-hmm.
answer of the multiplication? You are just multiplying this number with this number, and both of them are conjugate to each other.
Yeah.
Both of them are conjugate to each other. And what is the answer? What is the shortcut answer? They're just expanded it. This is the expand form. They're just writing it, and they're just expanding it, and they're just doing the multiplication things. And finally, they're just getting this answer. And if you're just gonna do A squared plus B squared, A squared plus B squared, you're just gonna tell in a very short amount of time. And that would be really so helpful for your ACT. Whenever you're just multiplying two different complex conjugate numbers to each other, then I'm just looking for some empty space here. I'm just looking some empty space here, and that's why I'm just scrolling. So what do you get basically? What do you get? You just get some. Just consider two complex number A plus IB and A negative IB. Both of them are conjugate to each other. Both of them are conjugate to each other. Both of them. If I ask the conjugate number of this number, the answer would be this. And if I ask you what is the conjugate number of A negative IB, the answer would be A plus IB. So both of them are conjugate to each other, And if you multiply them, if you are going to multiply them, the answer would be a squared plus b squared. No I term will remain here. And that is our main model. We don't want to multiply any number. We don't want to multiply, or we cannot multiply technically, maybe. We cannot multiply any number with a complex number. And that's why we're just trying to, and that's why we're just trying to bring, a real number, a real number. We're just trying to bring a real number to the denominator, to the denominator. Do you understand what I'm talking about?
Yeah.
And that's why we're just doing the conjugate. And that's why we're just multiplying the conjugate with the denominator and the numerator. Because why? Because we're just not interested to take any kind of complex number. We are not interested to take any complex number to the denominator. And that's why we're just taking the conjugate. Why? There is no necessity. Maybe there is no necessity to multiply with a complex conjugate number both in the denominator and the numerator, both in the numerator and denominator. But why we're doing it? Why we are doing it? Because we're just trying to get rid of the imaginary number from the denominator, and that's why we're just doing it. Okay.
Mm.
Do you have any questions?
No. Okay.
Okay, all right. So example number 2, in the equation x squared plus bx plus 4 equals 0, what are the possible values of b that would cause the equation to have only imaginary solutions? In the equations x squared plus bx plus 4 equals 0, what are the possible values of b that would cause the equation to have only one imaginary solution? So they're just asking you to do the quadratic formula. They're just trying to ask you to use the quadratic formula, and then you just need to find out, or you just need to do some things that will tell you what are the values of b might be, and what is the condition, what is the condition, OMG, my English is too bad. What is the condition of b? What is the condition of b? What is the condition of b? That is our main motto. That is our main motto. And to do it, you just need to think about this problem. You just need to, first of all, what do you need to do? That is the first thing that you need to do. That is, you just need to find the quadratic. You just need to use the quadratic formula, and then you just need to break it, and then you just need to tell what values of b be affected. What values of b be affected, and to cause imaginary solutions. And look at this, how they're solving this problem. This problem is quite well. This is a nice problem, to be very honest. It's a nice problem, and just look at it. Okay. So how they are doing it. First of all, they're just using a quadratic formula, which is for x, because x is the variable, and you just need to use the quadratic formula. You're just using the quadratic formula. And then you're just gonna find the discriminant part. The discriminant part is because we're interested to know the values of b. What is the values of b? Because we are just gonna take the discriminant part, and that would tell you what possible conditions might be. To have the different solutions, just like the imaginary solution. Because we're interested to think about the imaginary solution, this equation probably tell you. Because if you are using the quadratic formula, then the quadratic formula looks like this. And if you're just gonna map the quadratic formula with this equation, then you get the values for a, b, and c. the values for A becomes 1, the values for B becomes B, and the value for C becomes 4. Put them inside this equation, inside this quadratic formula, and then the expression you get that looks like this. That's look like this. That look like this. And then now tell me the condition. Now tell me the condition of B that will affect the equation and give you the output as imaginary solution. Now tell me the condition. Now tell me the condition. Now tell me the condition for B. Now tell me the condition for B that will affect you to cause this equation and to give an output for imaginary solutions. Okay, now think about it. Think about it. This is the, till now we have just come to this far. Till now we have just come to this far. And looking at this expression, we can tell this B is a real number. And this term inside the root, under the hood of root, under the hood of square root, can be complex, or can be real. And this whole number will be affected by this term, which is under the hood of root, square root. I repeat, this square. So what is the condition? This whole equation is affected by this green marked region. And what is the condition? What is the condition of this green marked region? Actually, basically, I should have just marked it by the red region, because it is really red. Okay, so it is a red zone, and this is the green zone. So how would be the green zone affected by the red zone? The red zone is such a number which has a square root and it is something. And we already know that this something has a lot of weightage of its positivity and negativity. So B squared minus 16 has a very high potential of affecting this whole term, and that's why we call that discriminant. Maybe we already know about that. We call that discriminant, and this discriminant can tell you how this whole term might be. So the only condition, it won't become complex or imaginary. That is only condition, that is B squared minus 16 is greater than or equal 0, right? Because the number under the hood of root need to be positive. The number under the hood of root need to be positive. Otherwise, you cannot tell that. It's not possible to tell that. It's not possible, or it cannot be positive, or it cannot be a real number. This whole thing cannot be a real number. The only way to get a real number is the way, or the only method is the term under the hood of root needs to be positive. And the only situation this whole expression can be imaginary is in that case when the number under the hood of root is going to be negative. And the condition of being negative, and the condition to being negative is, that is b squared minus 16 is less than 0. And if you just solve these problem by using the concepts of equality, then you get like this. B squared is less than negative 16. And then you just need to solve this problem. And to solve this problem, you get like this. You get the answer like this. And basically, b squared is less than 16. So it's a problem of the inequality. And I'm suggesting you to review the chapters of the inequality. Do you understand? Are you getting it simple, or is that complex to you?
Yeah, I get it.
Okay, you get it. Okay, all right. So -4 and 4. So if you're going to solve this problem, then you're just gonna get uh the value that is b negative. B is less than 4 and b is greater than -4. Okay, because you need
Mm-hmm.
to solve this inequality, and after solving this inequality, you get like this. And I'm suggesting you to solve. I'm suggesting you to read the problems of solving squared inequalities or something like that. So practice problem, we have some practice problem. What is the equivalent? What is the equivalent? Maybe they're just asking you what is the value of 3 I to the power 4. They're asking you 3 I to the power 4. So in that case, you need to know what is the value of I squared, what is the value of I cube, what is the value of I to the power 4. Please, you just need to, for at least at this moment, you just need to remember these 4 terms. It's like a cycle, okay? It's like a cycle. I -1, -I1. I -1, -I1.
Okay.
This is just like a cycle. I to the power 1 equals I squared equals -1, I cube equals -I3, negative I, and I to the power 4 equals 1. So the answer for I to the power 4 equals 1, I to the power 4 equals 1, I to the power 4 equals 1, and 3I squared equals 3. 3I squared equals 3. 3I squared is equal 3 I to the power 4 equals 3, because I to the power 4 equals 1. So 3 I to the power 4 is equals to 3 multiplied by 1 equals 3. That's it, as simple as that. What is 4I plus 12i? What is 59 minus 12i? What is 3I to the power 4? What is the sum of this? What is the product of this and this? We all know that. What is an equivalent form of this? What is the equivalent form of this? It's a nice question. The equivalent form is basically such a form. You just need to do some math, algebraic manipulation, and then you just need to simplify it. You just need to simplify it. You just need to simplify it. And how do you do that? Simplify it. Simplify it. -2I squared minus 3I plus 1. Okay, now just like this. 2I squared negative. What is the value of I squared? I squared equals -1.
-1.
I squared equals -1. So -2 minus 3I plus 1. And then negative. This is -1 minus 3I. And then the sign changes. 1 plus 3I. 1 plus 3I. The answer is correct. As simple as that. Which of the following is equivalent to the product of these and these? Product it. Multiply. Multiply. 1 plus 2I. 3I squared. As simple as that. Which of the following is an equivalent form of 1 plus I divided by 4 minus I? Complex conjugate. The concept of complex conjugate, taking the complex conjugate, both to the numerator, and the denominator. As simple as that. As simple as that. This is it, how we are doing the problems of complex numbers. I'm suggesting you to go through this, and this is basically concept called the real plane and complex plane. Let me show you. So some extra concepts. This is basically real plane. I should have used the green color. The real plane. The real zone is the real zone. The real zone is the real zone. The real zone is the green zone. I should have it. I should. Okay. But anyway, so this is positive x-axis, and this is negative x-axis. This is positive y-axis, and this is negative y-axis. Most of the time we tell that this is x, but this is basically the axis of independent variable. This is the axis of the independent variable. Just consider such an equation. V square equals to u square plus 2as, one of the most fundamental equation of physics. Motion, the problem of motion. Dynamics, v square equals to u square plus 2s. And you are asked to plot it. Okay? Plot this problem. Plot this equation. And how do you choose the variable? You just need to always look at the dependent variable. You always need to look at the dependent variable, and you need to look at the independent variable. Just consider S equals V equals U plus AT. V equals U plus AT, the most fundamental equation in one-dimensional kinetics. This is the most fundamental equations of motion in physics. So how do you plot it? You just need to take the independent variable in the x-axis in this direction. In this direction, we call this x-axis. Actually, it has just become an intuition for us, and that's why we always tell that this is the x-axis. But this is the axis of the independent variable, and this is the axis of the dependent variable. The x, most of the time, x is such a letter or such a symbol which always in every time it represents a variable, an independent variable, and that is the custom, or this is basically a tradition that mathematicians have developed. That is the custom, because they're always interested to make some customs. They're always interested to make some tradition, or they're always interested to make some tradition like this. And that's why x is always the tradition of becoming independent variable, and they're always telling that this is the axis of x, because x is the independent variable, and you cannot say, you really won't see any kind of equation in which the equation is consisted of x and the x is not an independent variable. The x is not an independent variable, because this is the tradition. This is the tradition. Okay. So convention. This is the word that I was looking for. Because the convention is you always treat x as the independent variable. So this is the variable of the independent variable axis, and this is the dependent variable axis. And in the concept of imaginary numbers, complex numbers, it is called the complex plane. Or the imaginary plane. Complex plane or imaginary plane. Although there are some slight differences, I won't talk about that. So this is the axis of the imaginary part, and this is the variable of the real part. This is the axis of the real part, and this is the axis of the imaginary part. And just for your simplicity, if we are just gonna plot 3, negative 2i, then how does it look like? then how does it look like? This is the axis of the real variable, plus 3, 1, 2, 3. This is the point, 3. Okay, this is our desired point, plus 3. And then negative 2i, negative 2i. Okay, so this is the axis of imaginary, and this is the positive imaginary, and this is the negative imaginary. So negative 2i is 1i, negative 1i, negative 2i. So this is at negative 2y, dot, 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 dot. This is the point, this is the location, this is the location where 3 minus 2y is located. This is called the complex plane. In some upper classes, you will also see some things. And one thing that I was talking about, that is the I plane. The I plane. Maybe there's some just like this, I squared, I cube, and I4. But it's just like a cycle, okay? Maybe I just forgot about that, but maybe it just look like this. Maybe it just look like this. They're just cycle, okay? They're just cycling around, and you just need to find out. You can just check it out on Google or something else, and they're just like sitting like maybe this is I, or this maybe is I squared. But I'm not sure, and that's why I cannot tell you which one is locating in which place. So just look at it, okay? Just search on Google, and then you will be able to find out these values. Just like blinking, blinking. Okay, you can just solve this problem. For example, I to the power 29. What is the value of I to the power 29? How to solve it? You can just check that cycle, just like this quadrant. It is divided like this, and there's a place where I to the power 1 is sitting, I squared is sitting, I cube is sitting, and I to the power 4 is sitting. You just need to find out whether it is order even or some there's some just some simple procedure. I just forgot about that, and that's why I'm not able to tell you at this moment. But you can just check it out on Google, and I'm just telling you what to find out, because this is it. I don't think the question will be tougher than this. We have covered a real-time complex plan. This concept was too much necessary, I think. Maybe they can ask you something like this. Maybe the plotting of a complex number. You can also check it out, because the real plane and the real axis and the imaginary axis. This is the axis of the imaginary number, and this is the axis of the real number. And a complex number is consisted of a real number and imaginary number. Mathematics is so beautiful, and basically wherever you just go, you just find some interpretation, or you just find some relationship with each other. Okay, you just find some relationship with each other, and this is how it works. You can just relate with basic algebra with some geometry. Okay, so this is the chapter how it ends, and okay, all right. Thank you.